Hi guys, welcome to your second of your last 3 math lessons of 5th grade. So you guys have, just one lesson after this. So hooray, you're just about there. So today we're going to be talking more about the coordinate plane that we introduced last week. So in your books, this is lesson 29, and it's going to start on page 290. So let's jump right in. So the first problem on that page says the coordinate plane at the right shows the layout at a country fair. Some of the booths are labeled. Meg is at a ring toss. She wants to go to face painting. Suppose Meg can only walk along the grid lines. Describe 2 different paths she can take. So this is a little bit different from how we were exploring the coordinate plane last time. Last time we talked about ordered pairs. Ordered pairs are kind of like the directions telling you how many spaces over and how many spaces up you need to travel to find a certain point. So in this example, they're using it as kind of a real world example, sort of, in that the points on the grid are representing booths at a fair. Now, I say sort of a real life example because in real life, we don't necessarily have to walk along grid lines, but it is getting you used to the idea that it's kind of like directions on a map. So, let's go ahead and first of all look at some of the important information in the question. So it says some of the booths are labeled. Meg is at ring toss. So I would go ahead and usually we circle the numbers in a story problem, but in this case I'm going to have you circle ring toss because that's going to be kind of like our starting place. She wants to go to face painting. Suppose Meg can only walk along the grid lines. Describe 2 different paths she can take. So I'm going to have you underline that last sentence, describe 2 different paths she can take, because that's what the question is asking. So even though it's not asking it in a question form, that's kind of the task for this problem is to find 2 different ways that she can go from one point at ring toss to the other point at face painting. A says, what ordered pair represents ring toss? So you'll notice that on your, so I've kind of written up some coordinate planes up here. And of course it's a little bit light, so it's difficult to see, but I have my y-axis going up and down. My y-axis goes to 11. The y-axis on the problem goes only to 5. I also have going horizontally my x-axis, again mine goes to 11, the problem goes to 5. So if we were going to be representing the problem on my coordinate plane, let's go ahead and start at ring toss, which is where Meg is at. So if we go to find ring toss, we see that it corresponds to this first intersecting point right here. So that would be the ordered pair. Remember, for ordered pairs, we go in order X and then Y, and it's written in this format with parentheses, X, comma, Y, end parentheses. So if we were going to do that, I'm going to try and move you guys a little bit closer in hopes that that will show up a little bit better. Okay. So if we were going to go ahead and create an ordered pair for our point for ring toss, we would see that we go over 1 on the x-axis. So as we are writing our ordered pair, we would write 1, comma, and then we also go up 1 on the y-axis. So we go over 1, up 1. That would be 1, comma, 1 as our ordered pair. So that's actually the answer to A, is what is the ordered pair that represents ring toss? 1, comma, 1. B says what ordered pair represents face painting. So you'll see for face painting that you would have your point here So once again, following the x-axis first, we're going to go over 1, 2 places. So the first number in our ordered pair would be 2. And then we're going to go up 1, 2, 3 to find that point. So our ordered pair would be 2, 3 for face painting. So now what the problem is asking is it's asking you to find a path just following the grid line. So obviously it would be quickest to go in a diagonal line from this point to this point. But the problem is saying describe 2 paths she can take if she walks along the grid lines. So, so let's go ahead and start with, I'm going to go ahead and switch to a different pen color. That, of course, is also light. Let's grab a different pen. Okay, now I'm back with a darker pen. And so we're going to create 2 paths. I'm going to write path 1 and path 2. So we are going to be figuring out 2 different ways to get from this point to this point following the grid lines. So if let's go ahead and first figure out how many over we would need to go to get from the first point to the second point. So if I went over 1, we'll notice that I'm now in line with the next point. And so then I would travel up 1, 2 points to get to that second point. So I could say move 1 to the right, and I'm going to just go ahead and, because I didn't allow myself a whole lot of space, I'm going to say move 1 right. And these are kind of like the directions that if you were to write directions down for your friend to get from your house to their house, or their house to your house rather, you would write, this is kind of like the standard symbol, is R with a circle around it stands for right, L with a circle around it stands for left. So we're going to move 1 to the right, and then we're going to move up 2. So our first path would look like this. We go over 1 to the right and up 2 to get to our second dot. Now, that's just one way that we can find our path. That's if we follow the x-axis first. But we could also go up first and then go over. So if I went up, I would still be going 2 spaces up to get in line with that first dot. So path 2, I would say move up 2. And then what that would bring me, if I went up 2, that would bring me here. And so then to get to my dot, I would move over 1 to the right. So I'm going to write that as my direction, move 1 to the right. So C, it says describe one way to move from ring toss to face painting. So we just described the 2 ways. So you could choose one of those 2 ways to write in for the first one. D says now describe a different path. So whichever one you wrote for C, write the second one for D. Okay. On page 291, it says on the previous page you use the coordinate plane to help you describe how to move between points, but you can do this without using the coordinate plane. You can use ordered pairs to describe how to move between points. So use the ordered pairs 1 and 1 and 2 and 3 to describe how to move between the points. So we have 2 ordered pairs. So we have 1, 1 and 2, 3 representing the first point where ring toss is and the second point where face painting is. So it says since 2 is to the right of 1 on the axis, the move is 1. So you're thinking of it as we're going to take our x-axis numbers and we're going to think of our ending place is 2. Okay. And then if we take away the 1, we would find that we have 1. And we find that that corresponds with our movement here, that we have 2, if we were going to move backwards. So we're describing how to move from this first point to the second point. But if we think about it in terms of the moves that we would need to make, we could also think of it as moving backwards. So we would see that we would move back 1 and then down 3. I know. Come here. Okay. And then the same thing for the y-axis. We're going to look at our 3 and our 1, and we would do 3 take away 1 equals 2. So these would correspond to the moves that you would be making. 2 minus 1, you would be moving 1 space up, and 3 minus 1, you would be moving 2 spaces, you would be moving 1 space along the x-axis and 2 spaces along the y-axis. No. Okay, moving on to question 1. It says, pick 2 other points on the coordinate plane on the previous page. Use the coordinates of the points to describe a path from one point to the other. So this is going to vary depending on the 2 points that you end up using. So you'll notice that there are other points. There's ring toss, which is the where Meg is starting, but there's not only face painting, there's also book sale and snack stand that are also booths that are labeled on that coordinate plane. So depending on where you would be wanting to move to, you're still starting at that first coordinate point 1, 1, but depending on what the other point is that you are going to be moving to, you would be adjusting your directions for how to get there. Okay, so I'm going to have you guys complete that one on your own, since it's kind of difficult to go over it because it depends on where you're going to be going to it. Okay, I'm back. So we're going to go ahead and move on to page 292 and work through the problems on this page and the next page. So this first problem, seriously. Okay, so as I said, we're going to be working through the problems on pages 292, 293, 294, and 295. And hopefully we can make this quick. Okay, so in the yellow box, Gabe has $8. He goes to an arcade where each game costs $1. Use equations, a table, and the coordinate plane to represent the relationships between how many games Gabe plays and how much money he has left. How many games can Gabe play if he wants to have exactly $2 when he leaves the arcade? So below you'll see there's the model it section that says you can use equations to represent the relationship between the quantities in the problem. So Gabe starts with $8. Each game costs $1. So you'll see the first equation says $8 minus $1 times a certain number of games is going to equal how many dollars he has left. So we know, and so they've modeled it with different equations. We know that we want that blue dollars left at the end to equal $2. So we know that we're going to have 8 minus $1 times a certain amount of times played equals $2. And they've worked through it. So they say $8 minus $1 times 1 would equal 1. And so you would have $7 left. $1 times 2 would equal 2. That would equal $6 left if you took it away from 8. 1 times 3 would be 3. You would have $5 left. 1 times 4 would be 4. You would have $4 left. 1 times 5 would be 5. You would have $3 left. And 1 times 6 would be 6. 8 take away 6 would leave you with $2. You can also model it using a table, as they've shown. So you have at the top number of games played, and at the bottom amount of money left in dollars. So again, using the same principle, number of games played, 0 games would equal 0 times $1 because you didn't play any games, and so you would still have the $8 left. 1 game would he would have spent $1, so you'd have $7 left, etc., until you get to 2, which is the end result of what we're aiming for. On the opposite page, it says connect it. So now you'll solve the problem from the previous page by representing the relationship between the quantities using the coordinate plane. So in the problem, it talks about how you can use table, equations, and the coordinate plane to solve the problem. So they've shown you the first 2 ways to do that, and now we're going to be exploring it on the coordinate plane. So question 2 on page 293 says, what quantity in the problem stays the same? So that's asking you, so the amount of money that Gabe has is changing, right? Because he starts with $8 and we're hoping that he ends with $2. There is a certain amount that stays the same no matter what the other numbers are, and that's the cost of the games. So we want to figure out how many times he plays, but the cost of the game stays the same. It's always $1 for each game that he plays. So what quantity stays the same? The cost of a game. The second one says what 2 quantities change? That would be the number of times that he plays and the money that he has left over. So our goal is to reach $2 when he leaves the arcade. But each time, as you'll go back and see on the other page, with both with the table and with the equations, what's changing each time as we adjust the number of games that he plays, we're also adjusting the end number of how much money he has left over. Number 3 says, look at the coordinate plane. What quantity is represented on the x-axis? So we're looking at the label down for the x-axis. The x-axis is representing in this problem the games played, so the number of times that he plays the game. So that's what you're going to write on that first line for 3. And the second line says what quantity is represented on the y-axis. So again, looking for the label to the side, it says money left in dollars. Number 4 says how much money does Gabe have after he plays 0 games? So that would, if our x-axis, I'm going to shift this up. So if our x-axis represents how many games played, and he's playing 0 games, then for dollars, he would have $8 remaining. So we would be starting at 0, 8 would be the ordered pair, because we're starting with 0 games played and $8 left over. Okay? Now it says, it says complete the ordered pair. So 0 games equals blank dollars. You would be writing 0 games would equal $8. Now it says complete the ordered pairs where X is games played and Y is dollars left. So, so again, if we look back to our table, we would have ordered pairs. So for each time that we play 1 game, so remember our x-axis is number of games played, we would go down $1 on our y-axis because each game cost $1. So if he played 1 game, then we would go down 1 from 8. But our ordered pair would correspond with the number of games played. So we would have 1 on the on the x-axis and 7 on the y-axis. So we would have a point there, and our ordered pair would read 1, 7. The next one, if we played another game, we would have played 2 games, and we would be $2 less than 8. So we would go up from the 2, but we would come down 2 from the 8 for a point right here. Our ordered pair would read 2, 6. Then we would have, if we played 3 games, then we would have $5 left. So we would have a ordered pair of 3, 5. If we played 4 games, we would have $4 left. So our ordered pair would read 4, 4. And if we played 5 games, we would have $3 left. With an ordered pair of 5, 3, 5 over on the x-axis and 3 up on the y-axis. And lastly, if we went 6 games, 6 over on the x-axis, we would go up to 2 on the y-axis because each time we're subtracting 1. So our last ordered pair would be 6, 2. At the bottom of where it says fill in each of the ordered pairs, it says plot each ordered pair in the coordinate plane. So you should have something that looks similar to mine. Again, mine goes up to 11, but you should have something similar that creates this kind of, I'm going to write this one in a lighter color. This nice line that's created that we are following. So each time we go down 1, we also go over 1. Number 6 says, how many games can Gabe play to have exactly $2 when he leaves? Which ordered pair shows that? So again, we found that if he played 6 games, he would have spent $6. His total of $8 before take away the $6 would leave him with $2. So our the ordered pair that would represent that would be the 6, 2, or he could play 6 games. Number 7 says, how can you use a graph to represent relationships between 2 sets of numbers? I'm going to let you guys answer that one on your own, but I want you to think about what is the purpose of displaying our data this way? When we look at data, we've talked in previous grades about how you can represent it with pictures on a picture graph, a bar graph, a line plot. So line plot would represent something that shows the frequency. Bar graphs are good at showing comparisons from one to another. So why would we show something on a coordinate plane or a graph like this? So one reason might be if we're looking for something that's a relationship like we saw here, we might be looking for patterns in our data. So the pattern that's created by the data from the number of games Gabe plays is it creates this nice line, and we can see that it's consistent. We go down, each time we go down 1, we also go over 1. And so that's consistent throughout. There will be other data points that you may end up graphing that are not as consistent, but that may show trends. So you may be able to see relationships between points of data based on their graph coordinates. Okay, number 8, I'm going to have you guys go ahead and complete on your own. So I would recommend coming back to it and filling it in. I'm going to turn the page, and now we're on page 294. The next problem says Mrs. Souter writes the following ordered pairs on the board. So she has M is 2 and 1. A is 2 and 5. T is 5 and 5. And H is 5 and 1. And if those numbers seemed arbitrary to you, They very cleverly spell out math. So, so Mrs. Sutter is writing the following ordered pairs on the board. The points represented by each ordered pair is a vertex of a rectangle. So remember, a vertex is where two sides meet. So sometimes we call it an angle or a point, but the technical math term for it is a vertex, where two sides meet. So each of these ordered pairs represents a point on a rectangle. She lists the vertices in order to name the figure rectangle math. What is the perimeter of rectangle math? So the first one says picture it. You can picture the rectangle on a coordinate plane. So if we were to, I'm going to go ahead and go back to my first coordinate plane here. And if I were to now write some of those new coordinates on there, I would have 2 and 1. So I would have 1 point right here. That would be point M. I would have A is at 2 and 5. So remember, we're going in order. So I would have 2 over and 5 up for point A. I would have 5 and 5, so I would go over 5 and up 5 for point T, and I would go over 5 and up 1 for point H. Now, you may notice that she listed the ordered pairs not in order. If I were to just do like x-axis, I would have 2, 1 and 5, 1. Or if I were to go in order, I would say 2, 1 and 2, 5 and 5, 1 and 5, 5. When we are working on the coordinate plane, well, that's not straight. When we're working on the coordinate plane, you can use shapes this way, and so notice that it said that the rectangle is labeled math for points M, A, T, H. And so that would demonstrate the path that you would be drawing. So we would draw a line from M to A, from A to T, from T to H, and from M, and from H rather to M. And so that would be showing us our rectangle on the coordinate plane. The reason we wouldn't want to be doing it in a different order necessarily, or just at random, is if we wrote like 2, 1 followed by 5, 5, our path would be traveling instead of from M to A and A to T and T to H. Our path would be traveling through our rectangle. So, the order of your ordered pairs can matter depending on what your outcome is if you're describing shapes on the coordinate plane. All right, so beneath that problem it says picture it. You can picture the rectangle on the coordinate plane just as I've drawn it up here. Model it. You can find the perimeter of a rectangle with a formula. Oh, I'm sorry. Oh my goodness. Okay, barring any further disruptions, I'm sorry for the choppiness of this video, we can hopefully complete this last page together. So we're now on page 295 answering the questions for the question on page 294. So 9 says, what are the ordered pairs for points A and T? So they've given you both of those on the other one. Point A has the ordered pair 2 and 5. And T has the ordered pair 5 and 5. So I would write them just like that. A, and then the ordered pair, comma, T, and then the ordered pair. The second part of that question says, which are different, the x coordinates or the y coordinates? So on these two, which numbers are the same? We have the x coordinate comes first, remember. So for A, we have 2, and for T, we have 5. for the y coordinates, a is 5 and t is 5. So which are different, the x coordinates or the y coordinates? The answer will be the x coordinates because those are the numbers that are different. And then it says write an expression to find the distance between points A and T. So in order to find the distance between them, the one, obviously we wouldn't have any distance with where they are on the y coordinate, but where we do have a difference is on the x coordinate. So we would start with the larger number, 5, take away the 2, and we would find a difference of 3 lengths. So the third part of that question says, write an expression to find the distance between points A and T, 5 minus 2, and you can finish that equation by saying 5 minus 2 equals 3. And then the final part of that problem says, what is the length of, and they have written it like this, AT with a line over it, that represents the line AT. So we've just plotted this line A to T, and we've talked about the difference. The y-axis is going to be the same. It's the x-axis that is different, and there's a space of 1, 2, 3 units that you would cross as you're traveling along the AT line. Okay? 10 says, consider how you found the length of line AT above. What is the length of line MA? So now we're talking about the difference between M and A. So again, if we look at the ordered pairs, we have M and A. Now the x-axis is the same. They are both on the plane of 2. But the y-axis is the one that's different. We have 5 and 1. So if we follow that same strategy of writing an equation, we would start with our larger number 5, take away 1, and we would find that there's a difference of 4 units in between lines MA. So the second part of 10 says, what is the length of MA? Blank units, you would write in 4 units. And it says, explain how you found this length. You can just write your equation. 5 minus 1 equals 4. That would be totally sufficient. 11 says, what is the perimeter of the rectangle? So remember, perimeter is the distance around the outside of a shape. So if we were to count up all of the units, we would see that we have 1, 2, 3 from lines A and T, and we have 1, 2, 3, 4 units from lines N and A. So far we have 3 plus 4. What we know about rectangles is that there are 2 pairs of equal sides. So we know that our corresponding side HT is going to have the same length as MA because we're dealing with a rectangle. So we know that MA is 4 and TH would then also be 4, so we're going to add another 4. And MH and AT would have the same distance. We know that AT is 3, so MH is also going to be 3 as well. Now you'll notice that I have 2 4s and 2 3s. When we're dealing with the perimeter of a rectangle, you can say 2 times the length plus 2 times the width is going to equal your perimeter. So in this case, our length would be the, from points AT and MH, that would be 3. Our width would be MA and HT, that would be 4. So we would have 2 times 3 is 6, plus 2 times 4 is 8. 8 plus 6 would be, I know that 6 plus 6 is 12. 8 is 2 more than 6, so I would have 2 more than 12, which would be 14. So the perimeter would be 14 units. So the second part of 11 says, explain how you found the perimeter. And we just stepped through that here. We know the length of 2 of the sides. We know that it's a rectangle, and so it's going to have 2 sides that are equal. We can follow the equation 2 times length plus 2 times width equals the perimeter to find what that number would be. Number 12 says, how can you find the vertical distance between 2 points on a coordinate plane? So that would be, vertical means up and down. So how would you find the distance between points that go vertically, M and A and H and T? You would start with the larger number and subtract the smaller number. So remember, we started with 5 and we subtracted 1, where our second point lies, to get a distance of 4 for both of those lines. And number 13 says, how can you find the horizontal distance between 2 points on a coordinate plane? So same idea, only this time we're going side to side instead of up and down. So we're dealing with points lines MH and AT. We would start with we could start at 5 and no, we wouldn't do that. We would start with 2 and 5. So we would have 5 take away 2, which would equal a distance of 3 along those lines. All right, the last 2 questions at the bottom, 14 and 15, I'm going to let you try on your own. And here are the practice pages for you to work on for this week. A quick reminder, remember, because we only have 3 lessons left, and this is your second of the 3, so that means that we have 1 lesson remaining. If you need extra time to finish up some of these, please know that this time is flexible. So work at your own pace. If you can get a lesson done in a week, great. If you can't, that's okay. I'm going to still put out the lessons on the videos, but you guys can go at your own pace. So that's kind of nice, and that's honestly a byproduct of the hard work that you guys have put in. Remember when I was pushing you guys so hard and we were doing multiple lessons at once? This is the result of that. You guys are now having a little bit more flexibility in your time because you worked so hard with that. So reach around, give yourselves a pat on the back. Good job. All right, practice pages in your practice book. I want you guys to be working on pages 315 and 316 and 317 and 318. So remembering that those are double-sided pages, so you have 2 of those, 315 to 316 and 317 to 318. All right, I've got to go deal with the screaming baby. I hope you guys have an awesome day, and I'll see you next time. Bye.